Welcome to this OST2 lecture about using PCR policy with TPM2 tools. This is a summary of what we learned about TPM2 tools and TPM2 policy in the previous lectures. We will use this knowledge to start making use of policy PCR. So what is a PCR policy? This is the ability to bind a TPM object authentication to specific PCR values. We already briefly discussed why this matters, because we can extend various components of the system, various properties of the system into the TPM's platform configuration registers. And from there, this means we can bind the TPM object use to the state of the system or to the value of a certain parameter, and so on and so on. Also, by using PCR policy and policy OR, we can create compound policies that can work in different scenarios. I have prepared here several use cases as examples. We just mentioned the binding of a TPM key to the state of the system. For example, the disk encryption key will not be unsealed unless the system is in a good known state, and this we can verify by having the PCRs at the specific values and using those values in a PCR policy bound to the child key. We can make a more specific use of PCR policy by extending the configuration file of our system or application into a PCR and then binding that PCR value to a TPM key that holds a secret. This way, the secret held within our key will not be unsealed unless the application configuration, the user configuration, or the system configuration are in a good state. By using two policy commands, policy password and policy PCR, we can concatenate the two rules into requiring both a valid user authorization and a specific device state to perform certain TPM operation. In this case, I selected the decryption of a file system. So how do we build a PCR policy? Well, we can use the TPM2 policy PCR tool, and of course the main question is, how do we provide the PCR values? The tool offers us flexibility, and there are three ways. We can provide a file containing a concatenated list of the PCR values. And we can obtain that list by using TPM2 PCR read. We don't have to figure out how to compute the hashes by ourselves. We can just perform TPM2 PCR extend and then TPM2 PCR read and have that stored into a file and then feed that file to TPM2 policy PCR tool. A better option in some cases would be to match the PCR values as they are right now in the TPM, and this is achieved by not specifying an input to the TPM2 policy PCR. In that case, the tool will know to require the PCR values to be read from the TPM. And as a last option, probably best for just some testing and trying and development, is providing the actual PCR hash values on the command line as an argument. When we use the TPM2 policy PCR command, it will modify the digest of our policy session, and we need to make sure to store that digest using the -l argument. If we want to read out certain PCR registers, it is good to specify which banks, SHA-256, SHA-512, and which PCRs to be included in the policy. Regardless of how we are providing the PCR values, we need to specify what are the PCR numbers and their hash algorithm by specifying the PCR banks. Is this SHA-256 or is it SHA-512? Do not forget the I argument. And -f is used when the input to the policy PCR tool is a file containing the PCR values. Again, this requires also the -i argument, so the tool knows the values correspond to these PCR banks and these PCR numbers. Without the -f argument, we can supply the PCR digest as arguments on the command line. And with just -I, we would require the tool to read the values from the TPM. This is an example of how to create PCR policy using PCR values prepared by PCR read. We are starting a trial session because we are crafting a policy. Then we're performing a PCR read and storing the digest to a file called pcr.dat. We are specifying the bank SHA-256 and the PCR number, in this case 23. Now we are ready to use our created trial session using policy PCR and specify that the input will come from our pcr.dat file, and the value in that file is actually the PCR number 23 from bank with the SHA-256 algorithm. Do not forget to use the -L argument to store the resulting policy digest. This is what we'll use to bind the TPM object to the policy. And of course, just the normal TPM2 flush context once we're done with our trial session and we no longer need it because we stored the digest. Now that we have our PCR policy, we'll use it the same way we did with policy secret. We'll create a primary key, and under that key, we'll create a child key that will be bound to the PCR policy using the -L argument of the TPM2_create tool. At the end of this TPM2create command, we have a sealing operation. We're sealing arbitrary data inside the TPM2 key. If you want to learn more about this, please check our lectures D in TC1101. This is the way TPM2 tools allows us to input arbitrary data during the creation of a child TPM key. The -I- argument here, and then the input from 1 to 8. Because the primary key does not have any special authorization, we can load the child key. But to unseal the data, we would have to satisfy the PCR policy. Here is how this happens. We start a policy session, and by using policy PCR, we extend our policy session digest with our PCR file. We need to specify which PCR value is in that file. And as we remember, this is the SHA-256 bank and PCR number 23. Once we have our policy digest ready, we can use that session to satisfy the TPM2 unseal operation using our child key, and what we'll see on our terminal screen in the output will be the arbitrary data that we stored, the digits from 1 to 8. After we're done, we have quite a few artifacts that we need to flush. We work with easy to understand examples so we can build knowledge gradually. What I want to show here is that complex authorization schemes using extended authorization policies are possible. By using different policy commands, we are concatenating different policy digests. So when the time comes for authorization of the TPM object, we would have to satisfy all of these policies. And by using the policy OR, we can have a situation where multiple users can authenticate using different sets of policies. And this is shown very well on this diagram here on the right from the Practical Guide to TPM 2.0, a book that is available for download free of charge, and we've mentioned repeatedly in TC1101 and TC1102. Performing two-factor authentication using a TPM is possible thanks to the extended authorization and the use of policies. Remember, using multiple policies is in fact using a logical AND, and we can have policies about the state of the system, or about the state of the TPM, or about linked to different properties. It really depends on your security requirements. And I would recommend once more the talk by Imran Desai about TPM 2.0 mutable policies.